Hello students, we're still in the redox unit, and today we're going to talk about relative strengths of oxidizing agents and reducing agents from experimental data. And the point of doing that is we're going to build tables of reduction half reactions. So we have this thing called a spot plate experiment, and I'm going to turn on a little video here and you'll be able to see me doing this with a few different metals and metallic ion solutions. So here's the video. So what you see here is what's called a spot plate, and I'm about to add copper metal horizontally across the top, so that's why you see Cu solid there. And then vertically I'm going to add copper solution, copper 2 positive ions in solution all the way down, so you see those blue puddles. Okay, in the next row, horizontal row, I'm putting zinc solid or zinc metal. So here's these zinc filings. I put all these in all the way across. Okay, and then you'll see I'm going to put zinc solution all the way down the second column. There's zinc nitrate in solution, so zinc nitrate. And then the third column is going to be lead solution. The fourth column is silver ions, and I put lead across the bottom, lead metal across the bottom horizontally. Okay, and now you can see some of the substances react with each other and some don't. Wherever you see that black precipitate or that gray precipitate forming, looks like fur, but that's a precipitate. It's reacting. It's spontaneous. It's just reacting. They touch, they react. But notice some of the puddles don't react. The substances there touch and they do not react. They are non-spontaneous. Okay, so now we'll go back to the lesson and we'll fill out our chart. Okay, so I'll have you, so the copper on the left, you can see that there was no reaction. The copper on the right is getting covered with these looks like fur, but it's silver precipitating on top of the copper, so silver metal. Okay, so and the one on the left there is no reaction, no spontaneous reaction occurs. On the one on the right there's spontaneous reaction. So the check mark indicates a spontaneous reaction and X indicates no reaction. So what empirical evidence did we collect? That means what observable evidence did we collect? Well, I see fur starting to grow, or I see silver, a substance is precipitating. A good chemistry description is silver metal, Ag solid, is precipitating on the copper. But the point is that Ag positive is grabbing an electron and turning into Ag solid. Okay, so, and the Ag positive is an oxidizing agent because the substance that's reduced or gaining electrons is an oxidizing agent. Okay, so across the top, those metal ions are oxidizing agents. The metal elements are reducing agents. And that's what our chart, that's what our spot plate looked like with all of our check marks and X's in place. So the first question is, which one of those is the strongest oxidizing agent? Well, if you look under the Ag positive ion, there's 3 check marks. So that ion is the strongest, and its reaction looks like that. It's gaining an electron and precipitating to Ag solid for 3 of the 4 reactions. Okay, what's the second strongest oxidizing agent? Well, the one with 2 check marks, copper 2. And the third one is Pb2 positive, which has 1 check mark, and zinc ion didn't have any check marks. There, we have just created a table of reduction half reactions. Okay, and if you'll notice, the OAs are on the left-hand side of the table. Those are all oxidizing agents right there. And on the right-hand side of the table, you have reducing agents. The strongest oxidizing agent I have is top left. Ag positive is the strongest oxidizing agent, the SOA. The bottom right on the other side is the strongest reducing agent, which is zinc. Okay? So the highest on the left and the lowest on the right are the strongest on the table. Okay, When we look at these reactions going forwards, they're reduction equations. And when we look at them going backwards, they're oxidation equations. All right, really important principle. Whenever the OA is above the RA, that indicates that we have a spontaneous reaction. So we can use this table without doing the experiment to determine if a reaction is spontaneous or not. And spontaneous means it just happens. They touch, they react. So take a look. Look at that check mark, which indicates that Ag positive solution was touching copper metal. Ag positive is the OA, copper solid is the RA. Because the OA is above the RA, check mark, it's a spontaneous reaction. It just happens. Let's look at another one. Pb2 positive is reacting with zinc metal. Spontaneous reaction, check mark. The OA is above the RA. Ag positive above lead. OA is above the RA, spontaneous. Now, whenever the OA is below the RA, you have a non-spontaneous reaction. We can force the reaction to happen, but it won't happen just by contact. Okay? So let's take a look at that one. Zinc 2 with lead metal. Zinc 2 ions and lead metal. The OA is below the RA, non-spontaneous. The reaction will not happen spontaneously. Pb2 and silver metal, non-spontaneous. Okay, so now if you turn to page 8 in your data book, you can see this chart, which is a table of reduction half reactions. And the 4 that we had on the last slide are on our table. There's silver at the top as the strongest of our 4, and then copper is below that, and then lead, and then zinc. Okay? It just so happens that this table has way more reactions than just our 4, and it still operates under the same principles. The top on the left side is the strongest oxidizing agent, and the lowest on the right side is the strongest reducing agent. Okay, so some of the questions I give you in your assignment there are, it says place the oxidizing agents on the left side with the strongest oxidizing agent at the top. We did that. Place reducing agents on the right side with the strongest RA at the bottom. We did that already. So there's the SOA, there's the SRA. Okay, how can you predict if a reaction will occur spontaneously? Well, if the OA is above the RA, it's spontaneous. Okay, so a few questions based on the table that you see in the bottom right there, the one that we just did before. What's the strongest oxidizing agent? Ag positive aqueous. What is the strongest reducing agent? Zinc solid. Which of the following is the strongest reducing agent? Silver metal, zinc ions, copper metal, or lead metal? Well, we can look at our table, and it would have to be the strongest reducing agent is lead metal, the lowest on the right side. Okay? Would the following react? Copper 2 with lead metal. Spontaneous. OA is above RA. Ag and Pb. Nope, they're on the same side. Zinc 2 with Ag. Nope, OA is below RA. Pb2 with zinc. Yep, OA is above RA. Okay, and there is the start. There's a whole bunch of questions to do that I'll have to go over with you in class, but there's the start of that lesson.